Okay, welcome back again, guys. So this is the part 3 of this. I'm going to deal with special angles, and we're still in pretend work, right? So since we talked about how you can find the angles, the ratios of the angles using a sine of theta and finding the answer and so on, right? So now we're having these special angles, right? So special angles are so much nice because they give us a ratio that we can actually know and that we can actually recognize and that we can actually memorize, right? So these are what you call the special angles. So if you press the sign of if you press the sign of if you press the sign of 0, you are always going to get 0. Oh, this is not working. So if you press the sign of 0, you are always going to get 0, right? And if you press the cos of 0, you're only going to get 1. And the tan of 0, you're going to get 0 as well. And the sine of 30, you're going to get half. The cos of 30, you're going to get square root of 3 over 2. And the tan of that, you're going to get square root of 3 over 3. And sin 45 being square root of 2 over 2. So that is the whole diagram of special angles. So it means that we're not trying to find those. It means that you're always going to get these values, right? So those are our special angles. So how do we use our special angles? So mostly we use our special angles when they tell us to solve anything without the use of a calculator, because they are assuming that we have identified this board, knowing all these values, right? So let me find an example that I can use to actually solve this, right? So let's try to find an example that you can use to solve this. They said, can you solve this without using a calculator, right? So as long as we are having that table that we talked about, you can screenshot that table and use it anytime, or you can copy it and paste it somewhere that you can be seeing it every time, so that you can be working with it every time, so that you can get used to these values, right? So if they said work this without using a calculator, we can always check our board, right? So we know that the value of sin 30 is equals to half. So we are going to place our half, and then our sine of 45, here that it is square root of 2 over 2, and our cos of 45, it is also root of 2 over 2, right? So it means that simplifying this now becomes easy. If you cannot simplify in this way, you can punch in the calculator from this stage, not from that stage, only from this stage, right? But if you can solve it like this, because you know that this and this are going to cancel each other out, because this is a negative and this is a positive, and they're the same. So it means that our answer is finally gonna be half is our answer. And don't forget that we don't put the unit because it is a ratio. Ratios don't have units, right? Yes. So if you are okay in this stage, we can move on. So again, this is checkpoint 4. It means that if you're okay with the whole work, you can take a screenshot of this checkpoint 4, or again, as I said, there will always be a link to the document. You can download it and work on it at your own spare time, right? So This is the work on special angles, right? So now we can move on with our work. So now let's focus on solving the 6 trig equations, right? So this topic it will lead us to be able to solve the general solutions in grade 11 and grade 12, right? But for grade 10 content, we only mostly focus on the basic of these trigonometric ratios. So remember that every information that you learned this far is very important, right? All those things that we learned, the special angles, the theorem of Pythagoras, and using the ratios to find the unknown sides, and also how to punch your info in the calculator to get is a certain angle, right? So now let's see how we can solve the trig equations, right? So when we're solving the trig equations, we just treat it as if we're solving solving for x, for example, right? All those methods that we use them in trig. They only differ at certain segments that I'll show you how you can tackle them, but the rest are just more of the same, right? So let's just see how we can handle this. Believe me, it's not hard. It is very, very simple with very, very simple steps. So in this case, they said sine of theta is equals to 0.8. Now they said solve for theta, right? We are solving for theta. So this is the simplest or the basic of this, right? So what you do on this side, because we know that we are trying to get rid of sine here to be left with theta, right? So it means the sine must be divided this side so that you can go that side, right? So it means that we are going to divide by sine this side, and also we are going to divide by sine, right? But when we are dividing with sine like this, we know that if we are dividing anything like this, we can always place it, this can always go on top and be right. So now this is the arc sine, we call it the arc sine. So this is going to go on top and it's going to multiply this 0.8 when this happens. So it means that it goes on top and be in this way. So how can we place it in that way? So it is very, very simple. You just take your calculator like that, and then on some other calculator it is written second function or shift. So you're going to press your shift, and then you're going to place the ratio that you're having, and in this case we're having sine, so you're going to press sine. So can you see it gave us that arc sine thing, right? So after getting this, what do you do now? It means that you're going to place the value that you have. In this case we're having 0.8, so this is 0.8, and then we can close our bracket. So if that happens, you're going to get the value of theta. So in this case the value of theta is 53.13 degrees, right? It's going to be 53.13 degrees. So it means that our theta is equals to 53.13 degrees, like this, right? Just like that. So let's look at the second example. So again, you are going to use the very same idea. Now we're having beta in terms of theta. As I explained that it's either beta, it's either theta, it's either alpha. It is the same thing. It is just a variable. So again, we're going to take tangent that side, applying that arc rule again. So it means that our beta will be equals to arc tan of what? Of 4.2. And again, it is just still the same tactic that we're going to use. Second function in other calculators, as I explained, it is what? It is second function, and then we're going to place the tangent, right? So we'll place the shift and then the tan, and then we're going to place the value that we have. In this case it is 4.2, so we're going to place 4.2 and then close the bracket and find our value as 76.61. So our beta is equals to 76.61 degrees. As simple as that, right? So again, let's find another example and work on it. So now we're having 4 cos theta is equals to 3. Now there's a slight change in this, but trust me, it is still the same thing. It's just going to use the same idea, right? Just like solving for x in algebra, we know that first thing first we deal with what is not needed, which is 4 this side. So we're going to divide by 4 both sides. So we're going to be left with cos of theta being equals to 3 over 4, right? And then again we're having cos theta this side. It means that we can apply that arc rule, right? So we're going to have our theta being equals to the cos of this, which is 3 over 4, right? But still we are going to use the same method. So it means that shift and then our cos this time, and then we're going to place what, 3 over 4, like we are having there, 3 over 4, and then you close it, and we found that our answer is 40 point, sorry, is it, no, 41.41. so it means that our theta is equals to 41.41 degrees, like that, right? As simple as that. And lastly, let's have a final example, right? So now let's finish off this last example, right? So having sine of theta plus 2 is equals to 2,65. Mind you, this and this, they are not the same. They are two separate terms, right? So it means that we are going to take to that other side. So this is going to be sine of beta being equals to 2.65 minus 2. So it means that our sine of beta will be equals to 0.65. And again, applying that arc rule, so it means that our beta is going to become sine of 0.65, right? So again, we can punch the calculator the way I showed you, and we find that our beta will be equals to 40.54 degrees, just like that. So that's how we solve our simple trig equations. So having said that, again, I'm going to leave you with checkpoint 5, right? Checkpoint 5. I'm going to you can screenshot this, or if you cannot screenshot, you can always download this using the link that I'm going to leave, and you can work on these questions. So it means that up to so far we're having 5 checkpoints which we're going to deal with in the answers, question and answers. And having said that, I will end this video here, and if you haven't subscribed, please subscribe and also share with your friends. They may need help with this, so subscribe and like and share. Thank you, and see you on the next one.